Space is a place of frighteningly vast distances. Just the thought that incredibly fast light takes 13 billion years to reach us from some galaxy can make one feel uneasy. But if we focus on the positive, the distance between us and Mars, just a dozen or so light minutes away, seems like a hop in space terms. And there are times when our cosmic neighbors seem incredibly close. Even the 4 light years to Alpha Centauri don't look scary compared to distant galaxies. It's insanely close, and there's no doubt that humanity will eventually reach our solar system's cosmic neighbors. But who are they, apart from Alpha Centauri? Few would name the stars neighboring our Sun, but don't worry, we'll cover that in the next couple of minutes, and also estimate how far away they are. Before we talk about the chances of finding life on our cosmic neighbors, let's first discuss how scientists can determine which stars in the sky are close to us and which are far away, and how they can be sure they're not mistaken. The concept of a parsec, which you've probably heard of from science fiction, is a unit of measurement that was introduced thanks to the use of parallax. The prefix par means parallel, and SEC stands for sector of gas, which is, of course, a joke. The actual meaning of acer is arcsecond, thanks to which we can use Apple devices to experience parallax in a simplified way. In fact, with the release of the iPhone 7, Apple introduced a new type of wallpaper that creates the illusion of depth when the phone is moved, simulating the effect of parallax. The term symbolizes the change in the apparent position of an object depending on the position of the observer. Try holding up your finger and closing your left eye while looking at it with your right eye. Then, quickly close your right eye and open your left eye. You should see your finger appear to jump to the side. This is the same principle that scientists use to measure the distance to nearby stars. If you move your finger closer to your eyes and repeat the procedure, you will see that it has shifted more than before. If you draw imaginary lines to your finger, you will get a triangle, one side of which you know well the distance between your eyes. The two angles at which the eyes are looking at the finger are also known, and finding the length of the remaining side, which will be the distance to the finger, is a matter of time. And now, put reason and great scientists, whole generations of hard work and huge formulas on this scheme, and you will get a method according to which the distance to the objects was calculated with excellent accuracy. Distances to thousands of stars, and even to the planets of our solar system, as well as the Sun itself, were initially determined using the parallax method. This method is based on observing how their position changes against more distant objects when viewed from different points or as the Earth rotates. It is not difficult to guess that objects that are too far away cannot be calculated using the parallax method since we are limited by the diameter of the Earth. Even when viewed from both ends of the planet or during a complete rotation, the displacement of distant stars will be negligible. Other methods are used for those objects. But what we are interested in are the nearest neighbors of the solar system, which can be reached by simple parallax and later refined using more accurate methods. It should be noted that even 10 light years is a huge distance. The distance is too great for us to judge the number of neighboring stars definitively. In order to determine the distance to something, you need to see it first, and among the stars, there are very dim brown dwarfs. Therefore, the question of a precise number of our nearest neighbors remains open at the moment. With brown dwarfs taken into account, it is estimated that there are 14 large neighboring stars at a distance of 10 light years from our solar system. Let's start our story with a tiny red dwarf, standing at a height of 154. If we were to send light directly towards it, it would take about 9 69/100 years to reach it, which is amazing. At least we know that this star is still alive, unlike some fairy dish that sent its light to us about 6,000 years ago. We see it as it was when the ancient Egyptians were building the Pyramid of Cheops, so what can we say about row 154? Not much. It's a very typical star, as red dwarfs make up more than half of the stars in the galaxy. Row 154 is 5 times smaller than the Sun in mass and 300 times dimmer in brightness, and is located in the constellation Sagittarius. Despite its proximity to Earth, it cannot be seen with the naked eye. Interestingly, 154 is characterized by intense X-ray radiation, which is greater than that of the Sun. This can be explained by the star's relative youth, as it is less than 1 billion years old. At the time of its formation, there were already algae on Earth. However, due to its proximity to the Sun, the star falls into the first category of astronomers' attention. Searching for planets around stars is incredibly difficult because they are very dim compared to stars, and 154's height itself is not particularly bright, plus it is close. At one point, one of NASA's missions was very interested in studying this star because theoretically, we could find a planet there that is 3 times the size of Earth. However, unfortunately, funding was not obtained and there wasn't much reason for the planet, which would need to have Earth-like conditions, to be located 4 times closer to its star than Mercury is to the Sun. Its orbit would be blocked, and the hypothetical Earth-like planet around 154 would always be facing one side, receiving too much X-ray radiation and too little red light for photosynthesis. Therefore, even theoretically, finding habitable planets around red dwarfs like 154 is extremely challenging. We don't really have anything to do with our lives, but our theories are still based on the Earth, so let's talk about Sirius instead. You don't need to get to know it twice, it's the brightest star in the night sky. If you put the Sun and Sirius at the same distance, Sirius will be 25 times brighter than our star. However, we shouldn't be deceived, there are much brighter stars in space in absolute terms than Sirius. For example, Rigel's luminosity is about 120,000 times higher than the Sun's. If you were to switch places between Rigel and Sirius in the night sky, Rigel would shine like a third of the moon. Nevertheless, Sirius is still a bright star. It is roughly twice as heavy as the Sun and almost twice as large as the Earth, so it has been known to humans since ancient times. It was worshipped in ancient Egypt, Babylon, and Greece, and that's where it all started. The name Sirius, which translates as shining, also refers to its location in the constellation Canis Major. According to legend, Sirius is the dog of Orion. The Romans even translated the star's name as Canicula, meaning little dog, because its morning visibility coincided with hot days, which later became known as dog days thanks to the star. Now, the word vacation is associated with the meaning of the word canicula, and school children all over the planet are happy to have it. What is this neighbor, located just 8.5 light-years away from us? Sirius is a great star of spectral class A1, and it has a tiny white dwarf companion, Sirius B, which astronomers jokingly call the puppy. This is really the case because Sirius B is 360 times dimmer than the Sun. However, it should be noted that there are much brighter stars in space than Sirius in absolute terms. Puppy is still well-fed, and in terms of mass, it is not inferior to our Sun, being one of the largest white dwarfs. However, this does not make the Sirius system particularly unique. There is every reason to believe that systems with 2 stars are more common in space than single stars, and our introverted Sun is a typical resident of the universe. If there is potential for life in this system from our point of view, then a terrestrial planet and conditions for liquid water would need to be located far from Sirius, as far as Jupiter is from the Sun, which is 4 times farther than the Earth is now. The year would last about 6 years, which is not the worst thing, but the worst is that Sirius emits much more ultraviolet radiation than the Sun. It is possible to forget, and therefore there are questions about ordinary free oxygen, and the weight of the Sirius puppy will also affect the orbit, and therefore the stability of conditions on the planet. In general, everything is very bad, and from the point of view of real research, even worse. Sirius is very bright, and despite its proximity to the Sun, it is very difficult to find a planet near it. Current scientific achievements allow us, in theory, to find only a planet with a mass of 510 Jupiters at a distance of 25 times farther than the Earth from the Sun. In 2008, such a test was conducted, and the result was predictable negative. Some scientists still believe that Sirius is not a binary triple star, and we still cannot conclusively refute them. Hubble tried to find another brown dwarf or some huge Jupiter, but he could not, although the theoretical calculations as a whole allow for the possibility of stable orbits within the system. Perhaps in the near future, we will study Sirius better, as it slowly approaches the Earth, and in the next few tens of thousands of years, it will shine even brighter. However, the distance will increase again, but we can say for sure that for another couple of 100,000 years, Sirius will be the brightest star in the sky, unlike our next neighbors. Wolf 359 is an insanely dim red dwarf. It is closer to us than Sirius and is located 7.8 light-years from the Sun, but much dimmer. It is impossible to see a planet with the naked eye in the sky. If we were to switch our Sun to Wolf 359, then Earth's round shape would disappear. Without a telescope, it wouldn't be visible, and during the day it would be 10 times brighter than during a full moon on Wolfie 359. We wouldn't have stopped if it weren't for its high cavity in two directions. The first reason is the potential presence of two exoplanets. In 2019, a team The first planet is 20 to 40 times larger than Earth and rotates twice as far away. The second planet is allegedly only 4 times larger than our planet and is located close to the star, close enough to allow the possibility of life. However, scientists quickly cooled their enthusiasm, as the amount of radiation that this hypothetical planet would receive would be many times greater than Earth's, making the existence of life unlikely. The planets themselves are still only candidates, as direct observation and confirmation of their existence is difficult. But scientists remain interested in Wolf 359 for two reasons. First, this star is located near the plane of the ecliptic, which means that if you were to look at the Sun from the Wolf 359 system, all the planets of the solar system would be visible at once. Hypothetically, if advanced aliens have scattered probes throughout the universe for scanning, then a probe on Wolfie 359 could easily discover the existence of Earth. And, in turn, by observing Wolfie 359, we may find a hypothetical probe studying us. Of course, these searches have not led to anything yet. Much more productive to scientists is the legendary star Barnard, another neighbor of our Sun. It is the second closest object of its type to us, or the fourth if you count Alpha Centauri, which is a triple star system. It approaches us so quickly that it creates the impression that it owed the Sun 100 kilometers. Except for the Sun itself, it is the fastest star in the sky, flying towards us at a speed of 110 kilometers per second. And if now Barnard's star is somewhere 6 light-years away, then in 11,000 years of our era, the distance will be reduced by a third and will already be equal to 3 whole light-years. By cosmic standards, this is insanely fast. We see it as it was at the time when the construction of the Pyramid of Khufu in ancient Egypt had not yet begun. There is not much interesting to say about its height of 154, as it is a very typical star, since red dwarfs make up more than half of the stars in the galaxy. Its height is 5 times smaller than that of the Sun, and its brightness is 300 times less. It is located in the constellation Sagittarius, and, despite its proximity to Earth, it cannot be seen with the naked eye. The only notable thing about its height of 154 is the incredibly intense X-ray radiation it emits, which is more than that of the Sun. This can be explained by the star's relative youth, which is less than 1 billion years old. When it was formed, there were already algae on Earth, but because of its proximity to the Sun, the star is among the brightest in the sky. In addition, it has X-ray radiation and is a bit lazy and slow-moving old guy, but this doesn't negate the fact that the temperature on the surface of this star, belonging to the red dwarf Barnard, is almost 3,000 degrees. It's worth respecting at least because, due to its proximity, it has become almost a standard in studying stars of this type. It's quite difficult to study them because they are dim and heavy, but it's slightly easier to search for planets than it used to be. Peter van de Kamp announced the discovery of 2 planets orbiting Barnard's star in 1960. The first planet was similar in mass to Jupiter, while the second was only half as large. However, Peter couldn't find confirmation of his discovery, even though he tried very hard. The Hubble telescope helped to clarify that planets with a mass greater than 5 Earths cannot orbit Barnard's star. It seemed that there was no hope left, but in 2018, an international team of astronomers announced that they had found a planet about 3 times the size of Earth, orbiting Barnard's star at more than twice the distance that Earth orbits the Sun. However, despite the accuracy of the calculations, Barnard's planet B still remains a candidate, although its existence was also confirmed in 2021. Furthermore, most astronomers give a 90% chance of potential life on a potential exoplanet. However, even if the planet is twice as close to its star as Earth is to the Sun, it will receive extremely little heat due to the coolness of the star. Sometimes the temperature on a hypothetical exoplanet is unlikely to be higher than -170 degrees. In general, the prospects for life are bleak with the other neighbors of Earth that have potential for life. However, the mighty system of Alpha Centauri, consisting of 3 stars, comes onto the scene, located about 4 light-years away from the Sun. 2 of the 3 stars in Alpha Centauri A and Alpha Centauri B, are of great interest as they are very similar to our Sun. Alpha Centauri A shines 1.5 times brighter and is slightly larger than our Sun, while Alpha Centauri B is slightly smaller than the Sun and shines half as much. The entire Alpha Centauri system is slightly older than the Sun, and visually the 2 large stars merge into one when observed from Earth. This is not surprising since they orbit each other at an average distance of only 24 times the distance between the Earth and the Sun. If the Sun were replaced with another star, in moments of closest approach, the star would be separated by a distance equal to that between the Sun and Saturn. The third member of the star system, Proxima Centauri, is a true runt. It is only 1.5 times larger than Jupiter and is a red dwarf. Even Barnard's star looks like a giant against its background. Proxima Centauri is also actively studied, but it is the 2 older sisters, Alpha Centauri A and B, that really excite scientists. They have been studied extensively, even peering into their atmospheres and finding similarities to the Sun, and conducting some of the most precise calculations of possible planetary and life presence. Many simulations were conducted and they conclusively ruled out the presence of giant planets. This is not surprising since 2 of the 3 stars are so close together, and Jupiter would face a sad fate between their gravitational influence. However, simulations showed that both stars have a so-called habitable zone, which is an orbit where theoretically stable planets with liquid water can exist. Unfortunately, due to the brightness of the stars, even taking into account the insane proximity of the Alpha Centauri system, it is difficult to say anything. In 2012, European astronomers claimed to have found an exoplanet around Alpha Centauri B, but its existence was disproved 3 years later. The situation is slightly better for the larger star, Alpha Centauri A. In February 2021, a candidate exoplanet was found there that is remarkably similar in size and orbit to Earth. It will be verified by the James Webb Telescope, and we still have yet to learn the outcome. However, the true king in this scenario is quite unexpected. In the search for life, the collapse of the Proxima Centauri system is not surprising on the one hand. As we mentioned before, it is slightly easier to find planets around dim stars. However, the exoplanet discovered there in 2016 is astonishing. It is also almost identical in size to Earth, but its year lasts only 11 days, which means it is much closer to the star. Considering that Proxima Centauri is a dim star, this is an ideal combination of factors. The exoplanet candidate receives 65% of the Earth's warmth, which theoretically opens the doors to the existence of liquid water. However, more recent calculations are less optimistic due to the proximity to the star. Potential Earth-20 receives an indecent amount of radiation, and since Proxima Centauri is a red dwarf, it periodically experiences powerful flares. For example, in 2017, a flare was recorded that according to scientists' data would have certainly killed the planet. All your life on a planet, even if one existed, is not so bad. There are several candidates for exoplanets in the Alpha Centauri system, some of which are also in the habitable zone. There is hope that the James Webb Telescope will help confirm or refute this data, but of course, Alpha Centauri is the main candidate for all organizations that aim for interstellar travel. There is, of course, the Project Daedalus, which aimed at the Barnard star, but this is rather an exception because scientists mostly dream about Alpha Centauri, and here dreams come up against harsh reality. Humanity has exactly one spacecraft that shows signs of life outside the solar system, Voyager 1, which was launched in 1977 and was actually designed for 5 years. It miraculously stayed on track and in 2012 entered interstellar space, but even it will not approach another star for 40,000 years, although it is not about Alpha Centauri. Voyager is heading in a different direction, as are the New Horizons and Pioneer 10 spacecraft. Their missions, like Voyager, were mainly focused on the inner part of the solar system. Specifically, nobody has sent anything to other stars yet. However, if Voyager had been turned around at the same speed and sent to Proxima Centauri, it would have reached it in 76,000 years. And mind you, this is one of the fastest spacecrafts in human history. Of course, there is also the Helios 2 probe, which was accelerated using the gravitational pull of the Sun to an indecent speed of 240,000 kilometers per hour. But even with this speed, it would take 19,000 years to travel 4 light years. There was a prototype electromagnetic engine from NASA that went even faster during testing. But even for it, it would take 13,000 years to fly to Proxima Centauri. Nuclear and thermonuclear reactor projects do not help much. They are either too dangerous, too expensive, or too slow. The laser sail technology is considered the most promising in the near future. According to this technology, a sail is deployed around the ship, just like in the old days, and solar radiation accelerates it for greater speed. This sail is pushed by lasers, and according to Robert Frisby's calculations, it could reach Alpha Centauri in 12 years. However, for this to happen, its diameter must be a paltry 320 kilometers, and the useful payload would be a canned food tin and a tennis racket. And there is also antimatter, engines powered by which can be incredibly efficient. However, the production of 1 gram of antimatter would cost several $1 trillion. Overall, the situation with interstellar travel is very sad. Either the necessary technologies don't exist yet, or they are just concepts, or they are too expensive, considering that interstellar travel has little practical value. It's clear that most scientists are focused on solving everyday problems. The bright spot on this background and hope for our generation is the Dragonfly project, which involves sending a very tiny sailcraft to Alpha Centauri. The goal of the project is to reach the star within 1 generation, but for now, it's just a concept. Strictly speaking, we need to study our own solar system better, and until we finally figure out Mars and potentially habitable moons of Jupiter, looking towards Sirius and Barnard star is premature.
The year is 2154. Our planet has been ruined by environmental catastrophe. In the movie Avatar, greedy prospectors from Earth descend on the world of an ancient hunter-gatherer people named the Na'vi. Their home is a lush moon far beyond our solar system named Pandora. Could such a place exist? And could our technology and our appetite for exploration one day send us hurtling out to reach it? In fact, the supposed site of this fictional solar system is one of our most likely real interstellar targets, until a better destination turns up. Pandora orbits a fictional gas planet called Polyphemus. Its home is a real place, Alpha Centauri, the brightest star in the southern constellation of Centaurus. At 4.37 light-years away, it's part of the closest star system to our Sun. Alpha Centauri is actually two stars, A and B, one slightly larger and more luminous than our own Sun, the other slightly smaller. The two stars orbit one another, swinging in as close as Saturn is to our Sun, then back out to the distance of Pluto. This means that any outer planets in this system, anything beyond, say, the orbit of Mars, would likely have been pulled away by the companion and flung out into space. For this reason, Alpha Centauri was not high on planet hunters' lists until they began studying a star 45 light-years away, called Gamma Cephei. It has a small companion star that goes around it every 76 years. Now it seems it also has at least one planet. That world is about the size of Jupiter, and it has planet hunters excited. Perhaps 2/3 of all the stars in our galaxy are in so-called binary relationships. That means there could be many more planets in our galaxy than astronomers once assumed. At least 3 teams are now conducting long-term studies of Alpha Centauri, searching for slight wobbles in the light of each companion star that could indicate the presence of planets. If they find a planet that passes in front of one of the stars, astronomers will begin intensive studies to find out what it's like. One of their most promising tools will be the James Webb Space Telescope, scheduled for launch in 2014 or 2015. From a position 1,000,000 miles away from Earth, it will deploy a sun shield the size of a tennis court and a mirror over 21 feet wide. The largest space telescope ever built, it will offer an extraordinary new window into potential solar systems like Alpha Centauri. With its infrared light detectors, this telescope will be able to discern the chemical composition of a planet's atmosphere. And perhaps whether it harbors a moon, like Pandora. One prominent planet hunter predicted that if a habitable world is found at Alpha Centauri, the planning for a space mission would begin immediately. Here's that star duo seen by the Cassini spacecraft, just above the rings of Saturn. To actually get to this pair of stars, you'd have to travel as far as the orbit of Saturn, then go another 30,000 times further. Or put another way, if the distance to Alpha Centauri is the equivalent of New York to Chicago, then Saturn would be just 1 meter away. So far, the immense distances have not stopped us from launching missions into deep space. In 1977, the twin Voyager spacecraft were each sent on their way aboard Titan III Centaur rockets. After a series of gravitational assists from the giant outer planets, the spacecraft are now flying out of the solar system at about 40,000 miles per hour. They're moving so quickly that they could each whip around Earth in just 45 minutes, twice as fast as the International Space Station. Voyager 1 has now traveled over 110 astronomical units. That's 110 times the average distance between Earth and Sun, or about 10 billion miles. But don't hold your breath. If it was headed in the right direction, it would need another 73,000 years to travel the 273,000 astronomical units to Alpha Centauri. When it comes to space travel, we've yet to realize the dream forged by rocketeers a century ago. A Russian schoolteacher, Konstantin Tsiolkovsky, inspired generations of space visionaries with sophisticated ideas about multi-stage launch vehicles. He imagined the construction of space stations in Earth orbit, and eventually vast permanent space colonies. In time, he predicted, we'd evolve into a whole new species, Homo cosmicus. Since then, rocketry's greatest advances have centered on ways of containing explosive propellants and methods of maintaining stable flight at high speeds. The problem is that chemical rockets are just not efficient for long-distance space travel. To reach the speed needed to enter orbit around Earth, 17,500 miles per hour, the space shuttle must carry 15 times its weight in fuel. And that's efficient compared to some other rocket systems. And you'd need to be traveling more than 25,000 miles per hour to break free of Earth's orbit and go anywhere else. A NASA study showed that to send a space shuttle-sized craft to Alpha Centauri in 900 years would take an unbelievable amount of fuel, 10 to the 137th kilograms of rocket propellant. Suffice to say, it's more mass than is in the entire visible universe. While only a very tiny percentage of NASA's budget goes to advanced propulsion, there are some promising ideas on the drawing board. Rockets powered by nuclear fuel, or plasma, a supervolatile gas. Huge sails pushed along by the pressure of photons from the sun. Ion drives. But to reach Alpha Centauri within a human timescale, we'll have to go with the most potent fuel in nature that we currently know. It's the science fiction fuel of choice, antimatter. In James Cameron's Avatar, hybrid nuclear fusion and antimatter engines power a mile-long interstellar spaceship. At a speed of 670 million miles per hour, this vehicle makes the journey to Alpha Centauri in just 6 years. Antimatter really does exist, as the mirror image of the universe we know. It consists of electrons and protons, but with their electrical charges reversed. Whenever it comes into contact with normal matter, the two annihilate each other in a ferocious blast of energy. Large amounts of antimatter were created and destroyed in the fiery dawn of our universe, the Big Bang. But somehow, in one of the great mysteries in science, we were left with a universe whose visible substance is almost all normal matter. The universe still produces antimatter through powerful collisions, such as a jet from a black hole slamming into a cloud of gas. When matter and antimatter obliterate one another, they emit gamma radiation that we can then detect with instruments such as the Fermi Gamma Ray Space Telescope. Fortunately, black holes aren't the only way to generate antimatter. In giant labs, like the Large Hadron Collider, scientists accelerate atoms to nearly the speed of light and blast them together to expose their fundamental constituents. Small amounts of antimatter can be made this way, but it's incredibly expensive. With a dedicated facility, the cost of producing it might come down far enough to produce usable amounts. And that's the hope of one researcher. Dr. Gerald Smith has been working for over a decade to find a way to trap this volatile substance and store it in isolation from the rest of the universe. Smith and his colleagues have designed a trap the size of a cigar case. It sits within a tank filled with liquid nitrogen and liquid helium, designed to cool it down to 270 degrees below zero. Once injected into this trap, antimatter particles are suspended by magnetic fields within a vacuum as empty as deepest space. But the problem is that anti-electrons, called positrons, tend to repel each other explosively. That makes it tough to store more than a few at a time. This team now believes it may have discovered a pathway to storing large amounts over longer periods of time. Their solution lies in combining positrons with electrons, forming an element called positronium. In theory, with the right magnetic fields, these electrically neutral atoms might be held indefinitely. When released under controlled conditions, ultra-high energy antimatter beams could turn out to be ideal cancer killers, or lead to revolutionary industrial applications. Or perhaps, one day, they could power long-distance spaceflight. It wouldn't take much. Antimatter is so potent that it defies common sense. A chunk the size of a small coin could propel the space shuttle into orbit. Smith estimates that once in low Earth orbit, a human mission to Mars would take as little as 10 milligrams worth. The basic idea of an antimatter rocket is simple. A beam of positrons is released into the engine core, where it annihilates the surface of a metal plate. That creates an explosion that propels the craft forward. Another design uses a sail. A cloud of antimatter particles reacts explosively to its surface, propelling it forward. Short of traveling to another solar system, there may be good reasons to contemplate developing antimatter propulsion. A preliminary mission would speed beyond the orbit of Pluto, sending back close-up images of dark planet-like objects that ring the solar system out in the Kuiper Belt. A longer-distance probe could reveal new details about the Oort cloud, a vast realm of comets that envelops the solar system. Once out there, it could sample particles that make up the interstellar medium, or send back unique data sets on dark matter, the invisible stuff that makes up the overwhelming portion of our universe. To make it all the way to Alpha Centauri within 50 years, an antimatter probe would have to gradually accelerate to around 10% the speed of light. That's 67 million miles per hour. It would then gradually decelerate as it approached its destination. At those speeds, hitting even a grain of dust could destroy the spacecraft, so it might be best to slow the journey down to a century or more. It's safe to assume for now that we would only send a probe to Alpha Centauri if we discovered a habitable world. There may be other choices in our solar neighborhood. They include Proxima Centauri, a red dwarf star 4.2 light-years away that may be gravitationally bound to Alpha Centauri. Beyond that, not quite 6 light-years away, is Barnard's star. Or there's Lalande 21185, a red dwarf 8.3 light-years away. We already know it has 2 Jupiter-sized planets. There are at least 22 stars within 12 light-years of Earth. And any way you look at it, the first interstellar voyage will be a quantum leap for humanity. The urge to reach out to distant horizons, to climb the highest peaks, to push ourselves past our perceived limits, seems to be a vital part of what makes us human. Yet, explorers of old set off not just because it was there. At times it was greed, hunger, fear, or despair that propelled them outward from their homelands and allowed them to endure their long journeys. Whether we attempt to make this leap to the stars may come to depend on how we regard this planet. To the physicist Stephen Hawking, the journey is imperative. I don't think the human race, he said, will survive the next 1,000 years unless we spread into space. There are too many accidents that can befall life on a single planet. Indeed, we can't foresee the impact of wars, social upheaval, or the course of human civilization in coming centuries. But today, we can see the often conflicting trends that could one day propel us out into the interstellar void. On one hand, The technological advances that might make such a mission possible could revolutionize many other aspects of life on this planet. The ever-increasing rate at which numbers of transistors can be placed inexpensively on computer microchips has become a metaphor for the advance of all technologies in this century. From a few thousand transistors on the first printed circuits of the 1970s, computer chips now have billions etched onto their surfaces. Even that number could seem amazingly small in another few decades. Many observers forecast a steep rise, even an acceleration, in the pace of invention and basic research, and for whole new solutions to the problems of energy, food production, health, and more. On the other hand, major periods of scarcity may loom. In the 20th century, the world saw the largest increase in its human population, from less than 2 billion up to 6 billion. The world's population is now around 6.8 billion. It's expected to reach 9 to 10 billion by the year 2040, with the biggest gains in Asia and Africa. According to a recent UN report, the world will have to produce 70% more food by the year 2050, and at least that much more energy to sustain its population. The scarcity of just simple clean water in some regions is already frightening. Now throw in environmental impacts, like rising sea levels, or the spread of deserts linked to a gradually warming climate. The culprit, to most scientists, is rising emission of greenhouse gases like carbon dioxide since the start of the Industrial Revolution. This map charts rising temperature readings from the year 1885 through to the present. In some places they've gone up by as much as 2.5 degrees Fahrenheit. Computer models project the trend out to the end of this century. Depending upon population growth, energy use, and conservation, temperatures could rise anywhere from 2 to 11 degrees more. Will technological advancements allow us to halt the degradation of our natural environments and increase the carrying capacity of our planet? Will we find ways to mitigate the impacts of war, natural catastrophes, or political upheavals? No doubt, if or when we launch our first mission beyond this solar system, the occasion will spur reflection on who and what we have become as a people, as a planet, just as the first missions to the moon and our neighboring planets once did. At first, we'll send a probe designed to relay basic information on what's there, on a world whose light we have only studied from afar. As this cosmic emissary makes its way across the void, we on Earth will continue to struggle in our pursuits of happiness and prosperity, or of mere survival. When it arrives, we'll scan the data for evidence of a world like our own, one that may harbor life. How will our perspectives on that world, and upon our own, have changed?
Closest neighbor, radical weather is the norm in the solar system. We do have our own extremes here on Earth, but they pale in comparison to the fastest, dustiest, wettest, and most brutal alien storms. On Earth, the sun drives our weather, and sometimes drives it wild. When hot and cold collide in the atmosphere, watch out. This is true locally and globally. But storms on other planets are bigger, badder, and stranger than their counterparts on Earth. Why is that? Because of the sun? If not, what else fuels their fury? The basic laws of nature, the rules of the game, are pretty much the same wherever you go in the solar system. But every planet has its own way of playing the game. Right now on Mars, the entire planet is being covered in dust. This global dust storm blocks 99% of the sun's rays from reaching the planet's surface. It's actually a system of smaller but still massive storms churning dust high into the atmosphere. Once it starts, it takes months for Martian skies to clear.
Mars is just the most dramatic weather in the solar system in some senses. It's very rare in the solar system you get a weather event that can take out the whole planet.
So if the basic rules of hot and cold are the same on Mars, why is the weather so different from Earth? For one thing, Mars is half the size of Earth. It's also 50% further from the sun, so it's much colder. The average temperature on Mars is minus 80 degrees. That's almost 130 degrees colder than Earth. And the atmosphere is extremely thin and composed mostly of carbon dioxide. But perhaps the most important difference is this: Mars is a global desert.
What would Earth be like without water? Well, it'd probably have a lot of dust.
There's no liquid water at the surface of Mars, and there's very little water in the atmosphere, and so there's nothing to sort of keep the dust down.
On Earth, dust storms are localized and short-lived.
The reason for that difference in scale is that the storms are generating their own weather on Mars, whereas on the Earth, they're slave to the weather that's going on around them.
In other words, on Earth, the global weather system creates dust storms. On Mars, the storms create a global weather system. Astronomers have always been able to see big Martian dust storms easily with Earth-based telescopes. But what they couldn't see was what caused them. That would require a trip to Mars itself. In 2003, NASA landed 2 rovers called Spirit and Opportunity on the Martian surface. Their mission? To learn more about the geology of the red planet. NASA engineers always assumed that as these 2 vehicles roamed the Martian surface, dust would build up on their solar panels.
If you have a lot of dust that's falling down out of the atmosphere and coating the panels, pretty soon you're not getting much sun to the silicon. And in fact, we thought that was what was going to kill the rover Spirit and Opportunity.
Only it never happened. The rovers didn't die as expected. As dust built up on the panels, somehow something would clean them off. But how could this be? NASA engineers were baffled until the rovers themselves saw the culprit. Martian dust devils.
It turns out that dust devils were sort of our white knight. They came along and cleaned off the solar panels just at the time we were expecting to start having some problems.
There are beautiful photos that actually show dust devils moving across the Martian atmosphere, and ghostly soldiers moving out there in the distance.
A dust devil is really an extreme form of rising hot air or convection.
And that hot air wants to go up, and it comes up just like, water going down a drain. Well, this is air that just spirals up into the colder parts of the atmosphere.
Whenever warmer air, which is less dense, rises up through cooler air, which is more dense, it rotates as it swirls upwards. Convection can be very powerful, strong enough to lift things up. On Earth, it lifts moisture, and that's how thunderstorms form. But on Mars, there is no moisture, so it lifts dry, dark dust and creates giant dust storms instead. Once airborne, Martian dust clouds absorb sunlight and heat the atmosphere. This supercharges the convection, lifting still more dust.
That produces more winds, which bring up more dust, and these things can spread up to thousands of miles across, or even, in some cases, they can envelop the entire planet.
And because the Martian atmosphere is so thin, it doesn't take much to get this cycle going.
You get a lot more difference between the surface temperature and the air temperature, and so the convection on Mars is very much more vigorous.
As a rule, Earth doesn't get the temperature extremes that Mars does. But sometimes, here and there in the deserts of Earth, convection can be very Martian-like. And we get dust devils, too. But at Arizona State University, Lynn Necrace makes dust devils to order in a lab to study them up close. He uses a vortex generator and substitutes lighter, dry ice for dust. What he creates is not an exact replica of how real dust devils form, but good enough to see how they pick up dust and debris.
Natural dust devils usually form from the bottom up, as opposed to tornadoes, which form from top down. So what happens when we turn this on, we have the airflow starting, and as the airflow starts to rotate from the fans down to the floor, we actually end up having the vortex form.
In other words, the vortex generator, basically a huge vacuum cleaner, imitates the swirling action of convection.
You can see here there's a wider base where larger particles of the dry ice are being swept up and gets wrapped up and tightens as it expands upward. The center of the core is where the majority of the lifting would occur.
Martian dust devils have been helpful, keeping the rovers clean. But could they actually be making a mess of the rest of the planet? Some scientists think there are so many at any one time, and they lift so much dust into the atmosphere, that together they trigger these much larger dust storms.
It starts wind patterns, and the air's warmer over here, and it's colder over here, and the air starts moving around. Pretty soon you're spreading dust over the whole planet.
And we found measurements that indicate there's up to maybe 200 dust devils per square mile per day during some parts of the summer.
And they can range from a couple of 100 feet tall to devils that stretch 6 or 7 miles high.
You can get just towering monsters of dust devils that we would never see on the Earth. The kind of maximum size dust devils you see on Mars are more like tornadoes on the Earth, where they're going up almost 10 kilometers. So these things are just real monster systems.
Back at Arizona State University, scientists blow crushed walnut shells as silicate particles in the Planetary Geology Wind Tunnel to replicate dust and wind conditions on Mars.
If we can understand and sort of replicate what's going on, then we can, in a sense, understand how the Martian surface has been changing and continues to change as time goes on.
Oddly enough, their studies reveal that it's easier for winds to loft larger sand particles into the air than smaller dust particles.
This is because there's cohesional forces and static forces between the very small, fine dust grains. We imaged the rover deck and actually found that sand seemed to have bounced onto the solar panels, and we can see the skip marks across the surface. Now, this is interesting because we don't usually see sand typically reach that high.
Dust devils on Earth never have the punch to produce that kind of chaos here. Lucky for us. But what would happen to Earth if a giant Martian-style dust storm did overtake us?
If you had dust storms of Martian size on the Earth, you would find your city being enveloped in an orange-tan haze.
Air quality plunges as the storm churns. Dust blots out the sun, shutting down photosynthesis. No plants, no food. Temperatures would plummet. 65 million years ago, an asteroid may have struck the Earth, creating these same conditions, wiping out the dinosaurs.
It's not going to happen on the Earth, though, because there's going to be rainfall and moisture condensing on the dust grains and so forth and dropping them out of the atmosphere. So it's very hard for something like that to spread in the climate conditions that we have on Earth.
Forecasting Martian weather may someday be just as important as forecasting the weather on Earth. If we ever want to send a manned mission there,
The word environment no longer really applies just to the meadow next door and the little stream down at the end of town. It's the whole inner solar system. I mean, that's really our environment now.
the sun's energy bathes all the planets. On Earth, it creates hurricanes. On Mars, planet-wide dust storms. But with almost no solar energy, distant Neptune produces violent and powerful winds. Where do they come from? And just how bad are they? If Neptune's winds were to travel to Earth, these alien storms would literally blow us away. The orbit of Neptune lies 3 billion miles from the Sun, at the outer edge of the solar system. There's a lot we don't know about this big blue planet. Neptune's jet stream winds blast as fast as 1,500 miles an hour in its upper atmosphere. But how? The sun controls the weather on Earth and Mars, but it barely reaches out here. No sunlight means freezing temperatures, an average of minus 392 degrees Fahrenheit. So if there's no sun and no heat, where do these incredible winds come from?
One of the interesting puzzles is that as you go further out in the solar system, you get further from the sun, the winds don't go down. You still get very strong winds.
The energy for Neptune's winds must come from somewhere, and scientists are working to figure it out.
Neptune's energy is certainly not going to be powered by solar radiation. In fact, the energy we detect coming out from the planet in the infrared as heat is 2.5 times the energy coming in from the sun.
So the planet is creating its own heat, not from its core, which is made of rock and ice, but wrapped around this icy center is a mantle of ammonia, methane, and water, all being squeezed by enormous pressure and generating tons of heat. So while Neptune is frigid on the outside, on the inside it's giving off a lot of heat. This heat may help generate Neptune's winds, but they're still too strong to come from the mantle alone. Something else is pushing them faster and faster. Earth has a hot core too, and it's a lot closer to the sun. So why don't we have winds like Neptune? For one thing, our oceans store and release energy, and that helps generate our weather.
It adds energy in places, takes it out in others, in a very complicated system.
This complicated system produces a lot of wind. And just where are Earth's fastest winds found? Surprisingly, not over the ocean. They blow instead over the top of a fairly modestly sized mountain. New Hampshire's Mount Washington.
The highest winds ever observed by human beings were right here on Mount Washington at 231 miles an hour on April 12th in 1934.
Mount Washington Observatory, a private non-profit scientific institution, is responsible for tracking the weather and climate atop the 6,288-foot tall mountain. This remote weather station, accessible only by snow tractor in the winter, has kept daily records for the last 76 years.
It's definitely one of the most extreme locations on the planet. We regularly see in the wintertime winds exceeding 100 miles per hour every few days.
Nowhere near as ferocious as Neptune, yet still pretty strong. But why does this mountain, 1/5 the size of Everest, produce such fierce gusts?
We're at a place where we have winds converging from various directions, coming from the Ohio River Valley, coming down from the St. Lawrence River Valley, coming up the eastern seaboard, all converging here in this area on top of Mount Washington.
The elevation change from the valley floor to the summit of Mount Washington is very significant for any mountain range. It's over 4,000 feet, so air is forced to go over the mountaintop and forced to squeeze in there, and is accelerated as it's squeezed over the mountaintop.
And they measure it every hour, on the hour, 24 hours a day, 7 days a week.
It's blowing over 100 out here right now. Ice is forming on the instruments more quickly. It's time to go up and de-ice the instruments, even though it's blowing over 100. We got to do it every hour now.
Ironically, Earth's uneven surface, which channels winds into powerful gusts on Mount Washington, ultimately knocks them down over time. And this is the big difference between weather on Earth and weather on Neptune. Earth has mountains that slow winds down. Neptune is as smooth as a cue ball.
It's not so much a question of you're driving them stronger, because you're not. It's just that there's nothing to slow them down.
Simply put, once Neptune's winds get blowing, there's nothing to get in their way. So what would an average Neptune wind speed of 850 miles an hour do to us here on Earth?
We have parking level winds in the Earth sometimes above 100 miles an hour. We consider that pretty dangerous. So if we sat with 900 mile an hour winds from Neptune on the Earth, we would probably start wiping out everything on the surface and scraping everything off.
Giant Neptune takes wind and transforms it into something extreme and almost unrecognizable. But orbiting just beyond the rings of Saturn is a small moon that does the same thing to rain. This is Titan, where an everyday rain shower would turn Earth into an explosive fireball. It's a cloudy day, and a gentle rainstorm starts. Here on Earth, you'd grab your umbrella and consider it a minor inconvenience. But this isn't Earth, and it's no ordinary rain. You're on Titan, a small moon of Saturn. And in this chemical downpour, you'd need more than an umbrella to protect you. The rules of Earth weather definitely don't apply here. But Earth and Titan are alike in a lot of ways. On Earth, we have a solid surface, a protective atmosphere, and plenty of water. All these things make life on our planet possible. There's really nowhere else quite like Earth anywhere in the solar system. But Titan comes close. Like Earth, it has a solid surface. And that's not all.
Titan has an atmosphere that's, in general, very similar to Earth's. In some ways, it's mainly nitrogen, like Earth's atmosphere. It's rich with organic material, also like Earth's atmosphere.
But similar isn't the same. Here on Earth, our atmosphere has a huge supply of water in it all the time, constantly evaporating and raining back down, like here on the Hawaiian island of Kauai.
Today we're on the slopes of Mount Waialeale, which is the cloud-shrouded mountain behind us. It rains over 40 feet a year here.
Earth's water cycle starts when warm, moist ocean air rises, forming clouds that eventually condense into rain. The rain falls back onto the land, where it eventually drains back into the ocean, starting the cycle again.
When water evaporates, it absorbs solar radiation. When water condenses, it releases all that energy into the atmosphere. And this transfer of heat helps to moderate conditions on Earth.
Earth's water stores as much as 80% of the sun's heat, helping keep our temperatures steady from the equator to the poles. Scientists theorize that Titan might have water or some other liquid that might produce a similar effect. And in 2004, when NASA's Cassini probe visited Saturn, it found some pretty good evidence to support that idea.
If you went to Titan and you were looking at the landscape, you would see something that in some ways would look almost familiar to you. You might see big mountains and valleys that were carved out by running liquids.
In fact, as Cassini flew past hazy Titan, its radar read the surface below. Scientists saw channels cutting across the surface, much like rivers on Earth do. Some as long as 900 miles. The first strong evidence of liquid on Titan.
There are large bodies of liquid on the surface of Titan. Nowhere else in the solar system except for the Earth are there any large bodies of liquid.
Could water, the liquid that carves Earth's mountains and valleys, also be carving these features on Titan's surface? Or could it be something else? The problem is that Titan is too far away from the sun. If it was water, it would be frozen solid.
It's about -300 Fahrenheit on Titan, so things behave very differently on Titan than on Earth. Because it's so cold, methane, which is a gas on Earth, is a liquid on Titan.
One mystery solved. But just because methane is a liquid on Titan's surface doesn't mean it's part of a weather cycle like water on Earth. So how do we know that this methane also falls from Titan's sky? That answer is shrouded in mystery, literally.
Titan is completely covered in a thick haze of smog particles, like a very, very bad day in Los Angeles.
Despite the haze, the Cassini probe once again revealed the answer.
We can see the upper clouds, and we can see evidence for rainfall because the clouds drop very precipitously. We hypothesize that we're seeing the effects of rainfall.
Methane rainfall.
We think that Titan has methane monsoons, so we think that sometimes Titan has a lot of rain that is able to carve rivers and leave large fluvial deposits on the surface.
Cassini's radar imaging also revealed large methane seas on Titan's surface.
If you have liquid methane on the surface in a lake, for example, that methane can evaporate off and become methane gas in the atmosphere. So you have kind of a cycling of methane between liquid phase and gaseous phase and between the surface and the atmosphere that's very similar to the water cycle that occurs on the Earth.
But methane is a flammable gas. So why isn't Titan on fire?
For any combustion, you need two things. You need both a fuel, which methane is, but you also need oxygen. And on Titan, you lack the oxygen. So the whole thing is basically a big fuel canister, but there's no oxygen with which to burn it, and so it's all very stable.
If it were cold enough here on Earth to produce methane rain, the oxygen in our atmosphere would create a worldwide firestorm. Luckily for us, that can't happen. Titan's methane cycle makes it both alien and familiar to us.
To me, Titan is very exciting because all the materials are so different, and yet these processes produce very similar landscapes to what we see on Earth.
Titan proves that where alien weather is concerned, looks can be deceiving. On Jupiter, it's all about size. Drop the great red spot onto our world, and it makes even our worst hurricanes look like a breeze. This is the biggest and oldest storm in the solar system, and Jupiter's most famous feature. It even has its own name, the Great Red Spot.
It's about 2 or 3 times the size of the Earth, which makes it the mother of all storms.
We've known about the Great Red Spot in Jupiter's southern hemisphere for more than 300 years.
When Galileo invented the telescope, within a few tens of years, people had seen the Great Red Spot, and it's still there.
Familiar yet mysterious. Nobody knows how the Great Red Spot formed. But scientists are finally probing below Jupiter's cloud tops to uncover more about this enormous alien storm. The storm is powerful. With wind speeds of 300 miles per hour, it rises miles above the surrounding clouds. On Earth, we have storms that seem similar, though smaller and milder. Hurricanes, also known as cyclones or typhoons, depending on where they form. They're our most destructive weather systems. But is there more than just a passing resemblance between Earth's cyclones and Jupiter's red spot?
When you look at the Earth from space, at a hurricane, it's this big swirling pattern. It's round, it rotates. Jupiter's big storms look big and round and cloudy and they rotate, but there the similarity ends.
In a hurricane, there is an internal core, which is called the eye of the tropical cyclone, and that's a region of very calm winds and no clouds, and usually has a size of about 10-20 kilometers in diameter. And then away from the eye, there is the eye wall. Those are really cloudy regions with a lot of rain. And as you move outward, there is a whole region of about a couple of 100 kilometers with very, very strong winds and very strong rain.
Hurricanes draw power from heat in our oceans. But Jupiter has no oceans, and the sun isn't close enough to power a storm as big as the Great Red Spot. So where does it get its strength? Part of the answer is Jupiter's size. It's the largest planet in the solar system, almost as big as all the other planets combined. This mass generates a very strong gravitational pull, which in turn creates interior heat that rises to the surface. Another piece of the puzzle may be Jupiter's hypersonic rotation. Despite being much larger than Earth, Jupiter's day lasts only 10 hours. In other words, it spins incredibly fast. Could energy from this dizzying spin feed the Great Red Spot?
The weather is really dominated by this fast spin. There's shearing between different latitudes, and that shearing, plus a lot of heat that comes up from the interior of this very massive object, 290 times the mass of the Earth, leads to very violent storms.
Both Jupiter's and Earth's storms spin around in a familiar spiral shape. On Earth, it's because of an effect called the Coriolis force.
I'm sitting at the North Pole, and I want to throw a ball down to a friend who's in Los Angeles. And so if I threw the ball in that direction, the Earth rotates, and the ball will end up in the middle of the Pacific rather than in Los Angeles. So it's like if the trajectory was deflected to its right. And that's what we call the Coriolis force.
This force spins storms clockwise in our southern hemisphere. But there is a stark difference between Earth and Jupiter. The Great Red Spot is in Jupiter's southern hemisphere, and yet it spins counterclockwise. This is because of some other powerful winds.
It's bounded by jets, which are moving in opposite directions. And so like a cog between two conveyor belts, they're just feeding energy and momentum into the system.
Jupiter's complex jet streams spin the storm into organized chaos. But the greatest difference between Jupiter's red spot and our storms may be Earth's solid surface. Once a hurricane hits land, it comes apart pretty fast.
Where they come over land or over mountains, their behavior is very different from where they form over the oceans, and over warm oceans in particular, where we get hurricanes. And on Jupiter, there's obviously no solid surface.
With no land mass to stop it, the Great Red Spot just keeps on spinning and spinning and spinning. Scientists hope to learn more about our weather by continuing to study the storm.
On Earth, there's a limit to how far ahead you can predict the weather. On Jupiter, we can forecast where the red spot is going to be months in advance. It's practical value to understand what makes weather on Earth so unpredictable, and aspects of the weather on Jupiter are much more predictable.
Unpredictable or not, Earth's weather never gets as violent as on Jupiter. That's lucky for us, because if we shrank the Great Red Spot down to fit on Earth, we'd be in for disaster.
On the Earth, we go up to Category 5 hurricanes, nothing but Category 10 hurricane here. Not much would be left.
Alien storms are vastly different everywhere you go in our solar system. Even our next-door neighbor, Venus. They say we're sister planets. Lucky the resemblance doesn't include weather. Otherwise, we'd get seriously burned. Venus may be our nearest neighbor, but somehow its weather is radically different from ours. The second planet from the Sun is a cross between a toxic waste dump and Death Valley, but even worse.
So it's almost a planetary definition of hell.
The temperature is 900 degrees Fahrenheit. The pressure on the surface is the same as half a mile below the Earth's ocean. And if that's not enough, the upper atmosphere of Venus is choked with sulfuric acid clouds and winds clocked at 250 miles an hour.
To get a comparison for Venus, the best thing to do is climb inside of your oven and crank it up. And then in terms of pressure, you're talking about deep sea diving. It's like nothing. There's nothing comparable on the Earth. It's just a very, very extreme object.
On Venus, there's just no escaping the heat.
If you built up a hot spot on Venus, the massive atmosphere would just carry that heat away and spread it around.
But Venus shines so brightly in the night sky because its thick clouds reflect almost all the sunlight it receives. In fact, some early scientists assumed Venus would have moderate Earth-like temperatures.
When we went by Venus in 1962 with a spacecraft, we thought we would find a surface at 90 degrees Fahrenheit, sort of like Miami, Florida.
We were dead wrong. Something else must be at work on Venus. But what? So why doesn't Venus cool off the same way Earth does?
On the Earth, for example, we have sunlight coming in, hitting the surface of the Earth. Earth warms up a little bit, but the oxygen and the nitrogen in the atmosphere don't impede the light, so when it gets released out in the infrared, it goes right through the atmosphere and leaves and goes into space.
But on Venus, the atmosphere is 97% carbon dioxide. giving a whole new meaning to the greenhouse effect.
It becomes very, very hard for the surface to get its energy out.
So Venus really taught us a lesson, that if you have a blanketing gas, a greenhouse gas, it can warm up the atmosphere tremendously.
But why does Venus have so much more CO2 in its atmosphere than Earth? The two have much in common. They're even called sister planets. They're almost the same size, have roughly the same amount of carbon, and billions of years ago, both had lots of water. But eons ago, their paths mysteriously diverged. On Earth, water fostered life.
The Earth has most of its carbon in life forms, in the trees and the animals. But if you took all that carbon that's in the near-surface rocks and burned it up or released it, you would then create an atmosphere very much like Venus.
Venus's close proximity to the sun made it too hot to sustain liquid water. Instead, its water evaporated into the atmosphere, trapping the heat deposited by the sun and creating a runaway greenhouse effect. Once in the atmosphere, the water molecules were exposed to solar ultraviolet rays that broke the molecules apart.
It really wasn't recognized by the scientific community how important the greenhouse effect was prior to going by Venus and seeing this amazing place where it was 900 degrees Fahrenheit, not 90.
It took several doomed missions to Venus to figure it out. Starting in the 1960s, both the United States and the Soviet Union sent unmanned probes past the planet and down to its surface. It didn't take long before Venus crushed and burned them. Then, in 1981, the Soviet lander Venera 13 set a record for survival on the surface of Venus. 2 hours and 7 minutes. It was able to take pictures and samples of the surface before being overcome by the heat.
You're sitting there with this 900 degrees Fahrenheit heat all around you. It's going to get in there and bake you after a while.
Scientists one day hope to send a probe to Venus that can survive its hellish environment, to help us confirm our theory of how this planet went astray. Because if circumstances were just a little different, our sister planet might just be our twin. Remove our atmospheric shield, and you're on the road to hell.
As soon as you're heated up to something like 400 degrees or so, you probably start getting some smoldering smoke, and way before it hit the 900 degrees, the Earth would burst into flames because all the oxygen around.
Once the oceans boiled away, the carbon locked in rocks on the ocean floor would cook, and over millions of years re-enter the atmosphere.
Probably if you came back to the Earth system after this happened, you'd find a planet looking much like Venus.
We're a long ways away from such a drastic change, but it's sobering to look at Earth's sister planet when the sister planet went on a very different track than we did.
So cosmic forces turned Venus into a planetary barbecue. But on this violent, stormy world, time and the elements have produced some of the strongest thunderstorms ever measured. Welcome to Saturn. Lightning cuts the sky. This violent weather system grows bigger than the entire United States as it pummels the atmosphere with the most powerful lightning ever seen. Except this lightning can't be seen, because these bolts are electrifying the skies over Saturn. Despite the raw power of Saturn's lightning, scientists have been unable to see it, partly because Saturn's rings are too bright.
The rings are so bright, if you were on the night side of Saturn, it would be considerably brighter than the Earth under a full moon.
But Saturn also hides its lightning within thick, choking clouds of ammonia.
It's probably 100 kilometers down that the lightning is happening, and that complicates seeing the lightning flashes.
But the lightning is there, and scientists know it because they've heard it. Radio wave detectors on the Cassini orbiter have recorded the sound of Saturn's lightning.
We can hear the static of lightning just as you could with an AM radio going down the highway on, on Earth.
And this static reveals the power of the lightning that we can't see.
You can measure the energy in those radio waves and compare it with the energy that your radio picks up when there's a thunderstorm around on Earth. And the Saturn ones are big. They're more powerful, maybe 100 times.
And Earth's lightning can help scientists understand how storms work on Saturn. Within Earth's storm clouds, just like in Saturn's, updrafts drive moisture higher, causing ice to form. These ice crystals rub against each other, take on a positive charge, and become attracted to negatively charged water droplets lower in the cloud. This sets the stage for a potentially powerful discharge of energy.
Once you get that charge separation that builds up so intensely that some theorize that it can be as strong as 100 million volts, that the cloud then must release that energy.
On Saturn, the same thing happens on a much larger scale. In fact, the lightning is 100 times stronger than Earth's. That's a staggering 10 billion volts of electricity. Thunderstorms in Saturn's southern hemisphere span thousands of miles and can last as long as a month. But scientists aren't sure what makes Saturn's storms bigger and longer lasting. It could be Saturn's supersaturated atmosphere.
Probably the fact that there's more water in the atmosphere, pound for pound, on Saturn makes the storms bigger.
More water droplets means more friction, which means bigger lightning bolts. But energy emerging from the planet may also contribute to the power in Saturn's thunderstorms.
It turns out that where Lightning Alley is on Saturn is a place where the winds are flowing the slowest. If you go deep down in the atmosphere, you'll see the same winds as you do up high. It's a place where the energy being released deep down below can make it on up to the upper atmosphere without being sheared apart, and it allows storm systems to be organized.
Earth's atmosphere isn't built that way. So, as violent as our storms get, they're nothing compared to the systems on Saturn. Even a run-of-the-mill mega thunderstorm on Saturn would devastate us here.
A Saturn-sized thunderstorm on the Earth would mean a thunderstorm that grows to cover all of North America and presumably has very strong winds and rain. This is something that's unprecedented on the Earth.
Saturn's hyper-violent thunderstorms are proof that our planetary neighbors have weather far more ferocious than ours. But the laws of physics that create Saturn's storms are the same laws that create our own weather. Massive dust storms, unrelenting winds, killer lightning, powerful hurricanes, and searing heat.
Tourism is big business. There's almost nowhere on Earth you can't go. But the ultimate destination may be 100 kilometers above your head. Space tourism visionaries are creating the next generation of holidays that are out of this world. The getaway of the future will be a trip to the stars, the opportunity to rocket far from the Earth. The 21st century spaceman could be you. This could be the ride of your life. The final frontier offers the greatest adventure holidays. Check into a luxury billion-star space hotel. Catch a game of football in zero gravity. Or treat your partner to a date with a difference by taking them to dinner, trillions of kilometers from home.
The Wright brothers didn't think there'd be hundreds of people having a meal going to London. I think that in my lifetime you will see resort hotels in orbit.
Stardate 2020. Your dream holiday starts here. Just $4 million buys a seat to fly a couple of 100 kilometers into outer space. This is the Galactic Suite Space Resort. Your room is a super deluxe pod with zero gravity as standard. And this room comes with the most incredible of views. The resort orbits the Earth every 80 minutes. It's possible to watch not just one spectacular sunset, but 15 every day. And this isn't science fiction. It's about to become science fact. In the Spanish city of Barcelona, a team of space architects are hard at work designing a space hotel fit for the stars. They're backed by a secret investor with $3 billion of cash to splash. And they're already taking reservations.
Never
before has the space been designed for tourists, where their comfort, needs and activities take on a different level of importance. What's important to us is to be amongst the first that can do it.
At his boutique hotel, Xavier plans a 3-bedroom deluxe suite. The hotel will travel around the globe at 30,000 kilometers an hour, 450 kilometers up. Xavier's even planned a holiday wardrobe for the space tourist. Check in and slip on a Velcro spacesuit. And you can attach yourself to a wall like Spider-Man. 38 wealthy wannabe space tourists have already booked their hotel rooms in outer space, even though the plans are still on the drawing board. But across the Atlantic, one man is betting on making your space vacation dreams come true even sooner. Just a few kilometers from the casinos, billionaire hotelier Robert Bigelow is taking the biggest gamble of his life.
I kept it a secret for a long time as to what my real ambitions were, trying to work like a dog and save money and take a lot of risks.
Robert made his fortune in hotels. Now he's set his sights a lot higher. But his plans came as a surprise back at home.
When I told my wife that I was going to do something like this, she said, "You're going to do what?"
Robert's idea is out of this world. He's taking real estate into space, developing a giant space station that gives new meaning to high-rise living. He intends it to be used for different purposes, as a home, an office, or a weekend retreat.
What we're out to do is try to create a safe, affordable environment that's larger and larger for people to do all kinds of things.
Okay, I'm in position, Dave.
Building in space is a costly exercise. The International Space Station cost a whopping $100 billion. Robert needed a design that would be far easier to construct and one that wouldn't break the bank to build. NASA came up with a solution. They were developing a huge, lightweight space habitat that inflates in orbit, making it cheap and easy to launch. But when NASA's research costs spiraled, the project was scrapped. Robert saw his chance and snapped up the plans.
These systems are extremely strong. They're not balloons. The best correlation I can give you would be comparing it to the tire on your car. And it's made up of multiple layers, steel belts, and other kinds of very strong materials. And that's the same way with our architecture.
But would the idea fly? There was only one way to find out. In 2006, Robert launched a prototype, hitching a ride on a Russian rocket.
In my mind, I thought, there's going to be all kinds of things going wrong. We're going to fail.
To everyone's amazement, not only did the station inflate, but it also managed to broadcast extraordinary live footage back to Earth.
Biggest shock was, oh my God, you know, what we're doing is working for real. It can't get any better than this.
Now Robert is building the real thing, a full-sized place in space. The launch party is planned for 2014, and the onboard entertainment promises to be spectacular.
We will also have many cameras on board our spacecraft, and on a large section of wall, see any number of different angles of what's outside, so you could get right up on the moon. Even though you're only in low Earth orbit, you might have the moon right in your face.
With limitless shapes and sizes, inflatable buildings could make almost anything possible in space. Imagine experiencing new sports that can only be played in the zero gravity of space. Join the crowd at the Zero Gravity World Cup in a gigantic orbital space sports stadium.
Come on!
This is the dawn of a new era of space tourism. The sky is no longer the limit. But some have been unable to wait to get their space fix. In 2006, Iranian-American entrepreneur Anusha Ansari became one of the first space tourists.
I believe that there is something inside us always attracting us to the night skies, maybe because we're made of stardust.
She paid $20 million to take a holiday at the International Space Station and made a video of her adventure.
Just having the opportunity to fly from one end of the station all the way to the other, it was great. And I tried to go really fast and show off that, you know, I'm made to be in space. I'm made to be an astronaut.
Everything on board was pretty relaxed, especially in the dining room.
It's the only place that you're allowed to play with your food. Any simple task that you do on a daily basis, you know, brushing your teeth, drinking water, just eating can be fun.
And in space, there's not much space. But this is a room with a view.
This is my sleeping bag right here, right by the best view from the world. And I can see the clouds, the Earth rotating by. I see the curvature right there. That was actually my favorite time to just, you know, look at the night skies. I felt like, you know, I could live in space forever.
Anusha's trip cost her a cool $2 million a night. But there's good news for the rest of us. In your lifetime, you could be taking your own, more luxurious, affordable space adventure.
10, 9, 8, go for main engine start. 6, 5, 4.
One thing stands between you and the ultimate holiday in space: gravity.
Space shuttle Atlantis, reaching the crest of its historic.
To overcome it costs a fortune. $500 million per shuttle launch. The rockets use vast amounts of fuel, held in gigantic throwaway tanks. It's clear that for space tourism to take off, some clever thinking was needed. So in 2004, millionaire space enthusiast Anusha Ansari set the world a challenge by funding a $10 million competition to create low-cost spacecraft.
The only thing that can drive innovation is competition, to make access to space faster, safer, easier, and cheaper.
Teams from around the world took up her X Prize challenge. But in Mojave, California, maverick engineer Bert Rutan was ahead of the game. He was already working on a secret spacecraft.
Can you do a dog? A dog?
Bert is an aviation legend. You might say he's light years ahead of the competition.
Okay, I'm going to do a lion. Okay, you ready?
He had already built a plane so lightweight, it flew around the globe on a single tank of fuel. And he smashed altitude records with Proteus, which soared to more than 63,000 feet.
Ready to go?
Now, he's set his sights on sending tourists into space.
Listening to those that have been in space, the way they describe it, it seems life-changing to look down on the planet. And a chance to go there and look at that? Wow.
Just 5 months after the X Prize was announced, Bert Rutan rolled out Spaceship One. It had taken more than 3 years to build. To escape Earth's gravity, Bert used an ingenious design, with not one plane, but two. An aircraft would carry the space plane beneath its fuselage and release it at 50,000 feet to rocket into space.
Release. Fire.
Pilot Brian Binney fired the rocket.
Good work. Good work. Holy! That was
He narrowly missed a collision with the mothership.
That's good, though. 350, suggest shutdown. Roger, shutdown.
Within seconds, he had crossed the boundary into space, 100 kilometers above Earth.
Boy, it's really quiet up here. I'm going to get the camera out. Roger that.
Billy was able to take a few snaps for the album, from the first privately built spaceship to reach space.
RCSC on.
Copy that, Brian. It's moving and it's green. The CTN's a little warm, but looking fine. 3, 2, 1, coming down.
The civilian race for space had been won. But for Bert, this was only the start of his dream.
If I could please invite onto the stage Bert Rutan, the designer of the first private spaceship, Spaceship One. Bert?
I'll tell you something. I have a hell of a lot bigger goal. And you know what that goal is? I absolutely have to develop a manned space tourism system that's at least 100 times safer than anything that's ever flown manned to space, and probably a lot more. I have to do that.
Bert's ambitions are shared by billionaire entrepreneur Sir Richard Branson, and together they have set their sights on helping you reach the stars. Thousands of kilometers away, at his private Caribbean island, Necker, Richard puts his mind to taking tourists into space.
I'm old enough to have seen the moon landing, and I assumed that I one day would go to the moon. But the decades went by, and government-run space agencies were not that interested in getting you or me into space. So, out of frustration, we decided to create a private spaceship company where we could get as many people as possible to be able to experience spaceship travel.
This is Richard's dream, to use Bert Rutan's spaceship technology to take you on the trip of a lifetime. On board a spaceplane, you'll jet 60,000 feet up, to then rocket at 5,000 kilometers an hour, up to outer space. Pop your seatbelt and float in zero gravity. Then, check out the amazing views. You'll coast 104 kilometers above Earth for 6 whole minutes, until it's time to go home.
The spaceship will glide serenely back to Earth, and my guess is that quite a lot of people will be itching to get back up again.
Today, rocketing to space isn't for the faint-hearted. Astronauts must train hard to prepare for launch day. They have to be super fit to handle the extreme force of gravity.
2, 1, booster ignition, and liftoff of Discovery.
But Richard Branson's business banks on just about anyone being able to fly, regardless of age or levels of fitness. Something Dave Clark, who must find future passengers, is all too aware of.
What if we had the spaceships and we had all these people signed up and then nobody was actually physically able to fly?
To find out if the average person could get into space, The NASCAR Center in Philadelphia has developed a custom flight simulation.
We've developed a centrifuge program to replicate as almost exactly what's going to happen to your body in your trip into space.
GX now, concentrate on your breathing.
And finding out how most people will react has never been done before.
The data that they have on centrifuge is mostly from the military. These are the most healthy, perfectly proportioned, physical specimens of the population. These are Top Gun pilots, whereas we have people's kids, people, overweight people, older people.
Now talk about your gene training profiles.
75 space tourists, including Richard, have volunteered to go for a spin. They are about to discover what 5,000 kilometers an hour feels like.
You got the training, you got the tools, you know what to do. All right, go. You're at Mach 2, climbing at 80,000 feet.
The trainers ratchet up the G's. This is as close as it gets to the real thing.
You're feeling the rush in the heart, you're feeling the pressure on your chest.
Coming up to Mach 3.
The adrenaline is flowing.
Here's your chance to catch your breath.
Thank you very much.
Richard, tell us, what was it like?
It was wonderful. I mean, it's so important to go through that so that when you actually go into space, you can just lie back and enjoy the whole experience and not be worried about, is your body going to cope?
Richard sails through the test. But will the oldest volunteer, scientist Professor James Lovelock? He's 91 years old, and he's hoping he too will be able to fly to outer space. Space tourists will feel the power of G-forces. During takeoff and landing, the heart struggles to pump blood to the brain. But with training, it is possible to avoid the dangers. By squeezing your leg muscles, you can improve blood flow, making for safer spaceflight.
Welcome back to Earth, astronaut. You are now our most senior centrifuge rider. You hold the record. Oh, good.
All 75 wannabe space tourists pass with flying colors, proving it is possible to fly into space, whatever your age or condition.
Did well. Did well, James.
The G-forces are quite brief, and the centrifuge has now shown that really anybody can do this flight. Stephen Hawkins is planning to go into space with us. He'll be able to put up with it. James Lovelock, the environmentalist, he's going to go into space with us.
Now, it's just a case of saving up to buy your ticket for $200,000.
We've got to try to come up with, clever ways of getting that price down and down and down. Every $10,000 we can get it down opens the market up that much more. And I think 50 years from now, hopefully literally hundreds of thousands of people will be able to afford to go into space.
Richard Branson had the vision to turn space into the ultimate tourist destination. Now, all he needed was a spaceship. Back in Mojave, following his X-Prize win, Bert Rutan and his team started engineering his space tourist dream.
What we're doing is important because it's doing something that's never been done.
Bert's prize-winning prototype, Spaceship One, carried just one pilot into space. There's not enough room for space tourists, so Bert scales up his spaceship and creates a version for 6 passengers. And it's built with the sightseer in mind. Each passenger gets a window seat next to an aisle. It's double the size of its predecessor, so it needs a bigger twin fuselage mothership. But safety is always a top priority.
We can't achieve the level of safety that you do with modern airliners because they've had 7 decades of maturity. However, I do feel that to fly the public, this should not be looked at it as a dangerous adventure.
But modern airliners don't have to re-enter our planet's atmosphere. Anything speeding towards Earth tends to burn up. Bert's determined to ensure his space plane will be hundreds of times safer than spaceflight today. So, he has developed a revolutionary way for his spaceship to re-enter the Earth's atmosphere slowly. The space plane's wings pivot 65 degrees. Its fuselage flattens into the airstream, creating stable drag, like a shuttlecock. Spaceship 2 is so lightweight and the drag so high, it rapidly slows down without heating up. Then, at 70,000 feet above the ground, the wings realign like a glider, and the craft touches smoothly down on the runway.
My solution was to find the very safest way to land a manned spaceship. To me, it was the simplest way of doing a difficult job.
October 2010. It's taken 5 years to develop Spaceship 2. Today, she's leaving the hangar for her maiden voyage. At Mojave Spaceport, there is only one question on everyone's lips. Will she fly? Richard and Bert have gambled their reputations and a small fortune on the odds that she will. They are about to find out.
Standing next to Bert, watching it get higher and higher and higher. Obviously, Bert was understandably extremely nervous. I was nervous for him and for us.
45,000 feet above their heads, it's the moment of truth.
10 seconds. We are armed. Release. Clear the plane.
Release.
Okay, it's gone. All good. Beautiful.
Yeehaw!
That's great. Beautiful flight.
She flies perfectly.
We got word back that it was flying absolutely beautifully. It was a tremendous moment. You know, we really are close to the dream becoming a reality.
Beautiful job, Steve.
The final frontier is one step closer. Soon, you could be taking your seat on this spaceship for your unforgettable 6 minutes in space. But for these stargazers, this is only the beginning. If they have their way, you could travel on their spaceship to an orbiting hotel for the ultimate space vacation.
A lot of my life has been about dreams. If you don't dream, you don't make anything. One day you might see a giant V floating around the Earth.
The Wright brothers didn't think there'd be hundreds of people having a meal going to London. I think that in my lifetime you will see resort hotels in orbit.
Staying at a space hotel, you can expect more than 5-star luxury. From here, you can gaze on an entire galaxy.
I think the important thing about being in a space hotel is that you have massive windows, and so you can look out at the universe around you and marvel at it.
And once you've been there, space travel agents will be booking your trip to the next holiday hotspot. Have you ever gazed up at the moon, tracking across the night sky, and wondered what it might be like to visit? To fly over its craters, we'll take a walk across the lunar landscape. At 400,000 kilometers from Earth, it would take you days to get here. So once you get here, you're going to want to stay around. In Las Vegas, Robert Bigelow thinks he can offer you the perfect place to stay. His inflatable space station could open as the first moon hotel.
What you have is an entire station that's really a potential lunar base. We would use low Earth orbit as the trial place of assembling these craft. And with a few modifications, we can turn these stations into bases.
Once you land here, Hotel Moon will offer the latest in cosmic comfort. This is one resort where they really will have thought of everything, including the breakfast buffet. In the arid desert near Tucson, Arizona, feeding lunar tourists is food for thought.
We're going to go to the moon, or we're going to go to Mars or beyond, and we have to survive. And unless we're going to carry a picnic basket of fresh vegetables and processed foods, which we can't do in the long term, we're going to have to grow our own.
If you're going to enjoy fine dining on the moon, you'll need a space food expert like Dr. Gene Giacomelli. He knows how to grow crops that are out of this world.
I find this very exciting, to be able to use agricultural technologies to grow plants to feed people like we do on Earth, but to bring that to space.
On Earth, our atmosphere filters out dangerous solar radiation that would otherwise wipe out crops, rainforests, and woodlands. But on the moon, there's no protection. For crops to survive, a greenhouse would have to be shielded. Buried underground to protect it from the sun, it could nurture crops with very little help from people.
The lunar greenhouse, in many ways, is a robot. It automatically provides its climate so that the plants grow in the way we want them to grow. It provides the temperature and the light, carbon dioxide, as well as the hydroponic system for nutrients and water.
Gene and his team have already built a prototype lunar greenhouse. On the moon, it would assemble itself, pre-packed with seeds ready to germinate. These plants don't even need soil. They can hang inside plastic envelopes, their roots bathed in nutrient-rich water.
But there it is. Nice roots, Dr. G. We're growing tomato, sweet potato, strawberry, and lettuce. And this certainly isn't a full diet, but it does offer the crunchiness of a salad, carbohydrate with sugar, and strawberry as a sweet fruit.
Lunar crops will generate drinking water and convert carbon dioxide into breathable oxygen, giving you not just a taste of home, but keeping you alive in space wherever you go.
The system certainly can be used on Mars and the Moon, but why not beyond? Why not in space stations and intergalactic traveling spaceships providing food and life support for the space travelers?
Getting to Mars on today's rockets depends on planetary alignment. The flight is only possible every 2 years, and the trip takes 7 months. Once there, you wouldn't be able to set off for home until Earth realigns again, 18 months later. So engineers and scientists have been looking for a much faster way to fly. Houston, Texas. Behind these shops, in a seemingly bland warehouse, a multi-million-dollar experiment is underway that could put Mars on your space trip itinerary. Franklin clocked a record-breaking 7 trips on the space shuttle. As the wheels touched down on his final NASA mission in 2002, his need for speed grew. He needed a faster set of wings.
Right off the bat, we know that we need something entirely different, something that would get us to speeds that are maybe 10 times faster than what we could do today.
Scrapping conventional thinking, Franklin throws away the rulebook and works out what the problem with speed boils down to.
The fundamental issue of rocket propulsion is that you want the exhaust to be very hot, and the hotter the better.
So, Franklin cooks up a revolutionary new rocket engine. It's powered by one of the hottest things known to man, plasma, and it's about to be fired up inside this vacuum chamber. The rocket is powered by hydrogen gas, which when heated turns into pure plasma. Powerful magnets push the plasma through the engine to supercharge the spaceship. Plasma is so powerful, you could jet around 4,000 kilometers in a minute and rocket to Mars at 200,000 kilometers an hour, slashing a 7-month flight to just 39 days, with 2 weeks rest and relaxation when you get there. That's a 100-day return trip compared to 3 years flying today's rocket ships.
All my life, I've dreamed about going to Mars and beyond. Space is like a drug, you know, once you get hooked, you don't want to give it up.
In Los Angeles, science fiction is becoming science fact. NASA scientist Dr. Kevin Grazier advises Hollywood on science fiction. And he thinks what you see on the big screen could be just around the corner.
The days of a few astronauts, cosmonauts, going into space, that's over. In the not-too-distant future, we're going to see you, me, regular people going into space.
Kevin thinks science will let us boldly take a holiday where no man has done so before.
A really far-out propulsion system that NASA has actually looked into is antimatter.
Buckle up for a journey on board your intergalactic space liner powered by antimatter. A look under the bonnet reveals a magnetic chamber that contains antiparticles. They're fed through magnetic rings to collide with their nemesis, matter. In just a nanosecond, billions of explosions create an enormous surge of energy, 10 million times more powerful than today's rockets, with a top speed of just over 1 billion kilometers an hour.
Distances to the planets are puny compared to the distances to the stars and galaxies beyond. If we're going to go to places further than our solar system, we're going to have to speed things up quite a bit. Enter wormholes.
Even flying at light speed to our nearest major galactic neighbor, Andromeda, gives new meaning to long haul. It's a 2.5 million year flight time. So if you're going to cruise beyond the Milky Way, you're going to need a serious shortcut.
The name wormhole comes from an apple. Imagine a worm on the surface of the apple who wants to get to the other side. He can do it one of two ways. He can walk all the way around the outside, or he can chew through the middle. The second is a lot shorter, and that's the basic principle of a wormhole.
If we could bend space-time, we could create a wormhole. a time-saving tunnel that connects two places trillions of kilometers apart. Wormholes might already exist and could become your intergalactic freeways to mind-boggling vacations.
One day you might board your shuttle for Wormhole Express at LAX or Heathrow, take that shuttle to your Starliner, and zap!
Do you fancy a vacation trillions of kilometers from Earth? To holiday in a floating city? To soak up a different sun in a distant galaxy? In the future, we may think nothing of traveling throughout the universe. By having fun in space, tourists could create unimaginable new inventions that would reshape our world. Just as the home computer was initially used for simple gaming, it's now the bedrock of our everyday lives.
The people that will be flying in commercial space flights are allowed to be creative. There's going to be 2 or 3 people that come up with something that's called a breakthrough. And all of a sudden, commercial space travel will look completely justified rather than look at, well, these are just joy rides.
Space tourism could take us all to new places and might ultimately ensure our survival.
Earth is the cradle of humanity, but one shouldn't remain in the cradle forever. Single-planet species don't last. Ask a dinosaur.
Pushing out beyond Earth's orbit will truly become a space species.
I cannot envision all of humanity remaining on this planet. Humanity's destiny is in space.
It's not a matter of if the commercial space industry will take off, but when. It was just over 100 years ago that the Wright brothers flew their first airplane, and now we don't think a thing about jumping in an airplane and flying across the continent or across the largest ocean. Today's commercial space pioneers who are just tickling the edge of low Earth orbit are today's Wright brothers.